Hello students, in this video we'll see how to find the equation of the plane given 3 points on the plane. If we're given, for example, given 3 points, 1, -1, 2, 2, 0, 3, and 4, 1, 2. I have 3 points. We know that as long as those 3 points aren't on a line, then they will lie on a unique plane. Let's find the equation of that plane. I'm going to treat these points, I'm going to treat this first point over here as my reference point. It doesn't matter what point you treat as your reference point. I'm going to look at those 3 points in space. And I know that A is a point on my plane, and I know that the vector from A to B and the vector from A to C are vectors on my plane. So the vector AC, which is what? Well, how do we find AC? We do AC will be a 4 minus 1, which is going to be a 3. Then it's going to be a 1 minus -1, that's going to be a 2. And it's going to be a 2 minus 2, that's going to be a 0. So AC is the vector 3, 2, 0. That's a vector on my plane. If I connect 2 points, A and C, that's going to be on my plane. So we can geometrically visualize that as follows. So if here's A, here's B, and here is C. What I'm doing with AC is I'm connecting this vector over here, and that vector has to be on the plane. Likewise, the vector AB is going to be on the plane. And we can see that, and I can basically think of the plane as being a tiling of these parallelogram over and over and over again. All right, so what's AB? AB is going to be what? It's going to be 2 minus 1, that's going to be a 1. Then it's going to be 0 minus -1, that's going to be a positive 1. Then it's going to be 3 minus 2, that's going to be a positive 1. So 1, 1, 1 is the vector on my plane. Now we can use the parametric version of our plane, and that's actually quite simple to do. So if I look at R of U and V, which is going to be A, the reference point A, which is going to be 1, -1, 2, plus U times one vector on the plane. I'll call that point 1, 1, 1, plus V times the second vector on the plane, the independent vector 3, 2, 0. That gives me a parametric equation of our plane. So this is a parametric equation of the plane. In other words, given a point and 2 vectors emanating from that point on the plane, you can parameterize the plane as follows. Now we can put the plane into a more symmetric form by finding the normal vector and finding the normal vector form of the equation. So let's find the normal vector of this plane. We'll see they're identical to each other. So what's the normal vector? It's going to be AB cross AC, or AC cross AB. It won't matter, it won't change anything. So let's do this cross product over here. So what we'll have is we'll have the determinant of I, J, and K, and then 3, 2, 0, and then 1, 1, 1. So what will this cross product give us? Let's look at the I entry. The I entry, I'm going to look at this subdeterminant over here. So the I entry is going to be what? It's going to be a 2 times 1 and 1 times 0, so I'm going to get a 2I hat. If we look at the J entry, what's going to happen? I'm going to have a 3, 0, 1, 1. So that will be 3 times 1, which is 3, minus 1 times 0, which is nothing. So I get a positive 3, but the J is always negative. So the J is going to be -3, so that's -3 J hat. And finally, the K hat's going to be what? It's going to be a 3 minus 2. 3 minus 2 is equal to 1, so I'm just going to have a plus K hat. So that is the normal vector to my plane, or at least one orientation of my normal vector. So now we know the equation of the plane. The equation of the plane is always going to be R minus a point on the plane, x0, y0, z0, dot n hat is equal to 0. Of course, the vector r is the vector field position, so here the r is the vector field position, x, y, and z. Good. All right, so now we have, what will our equation of a plane be? It'll be x minus the x point. Let's call that point a1. Y minus the y point. Y minus -1 is y plus 1. And then finally, z minus the z point. The z point on A is 2. So z minus 2. I'm going to dot that with what? I'm going to dot that with the normal vector. The normal vector is 2. And then a -3. And then a 1. And that will be equal to 0. So what will we have over here? We'll have 2x. We'll have a 2x, we'll have a -3y, and we'll have a plus z, then we'll have a -2, then we'll have a -3, then we'll have a -2 equals 0. So we can write this in more standard form as 2x minus 3y plus z. And then over here, what do we have? We have a -4 and -3, that's -7. So I'll add that to the other side and get a positive 7. And that is the symmetric form of the equation of our plane. Thank you very much.